Blockchain technology has reshaped how we think about money, data, and trust. Bitcoin introduced a decentralized ledger that operates independently of banks. Ethereum brought smart contracts that can execute complex rules automatically. And countless other blockchains have followed, each offering unique solutions and innovations. Yet, despite this remarkable growth, a fundamental problem remains unsolved: fragmentation. Most blockchains today operate in isolation. Bitcoin is highly secure but limited in functionality. Ethereum is programmable but struggles with high fees and congestion. Solana is fast but sometimes sacrifices decentralization. Other chains like Polkadot and Cosmos attempt to solve the interoperability problem, yet even they rely on patchwork solutions. For users, this fragmentation means juggling multiple wallets, wrapped tokens, and cross-chain bridges. For developers, it translates into extra work, duplicated code, and complex cross-chain interactions. For businesses, it creates barriers to adoption and integration. Imagine a future where all blockchains communicate natively, where digital assets, applications, and users can move seamlessly across networks without friction, intermediaries, or confusion. This is the vision that the Internet Computer Protocol, ICP, is bringing to life. By designing interoperability at the protocol level, ICP is not just another blockchain. It is the framework for a connected, cross-chain Web3 universe. In this video, we'll explore why ICP represents the next evolution of blockchain interoperability, how it works, practical applications, real-world examples, and its long-term implications for the blockchain ecosystem. Stay with me, because by the end, you'll understand why ICP is more than a technical upgrade. It's a paradigm shift. This video is created for educational and informational purposes only. It does not promote or endorse any financial product, investment, or cryptocurrency. All information presented here is based on publicly available sources and independent analysis. Viewers are encouraged to conduct their own research before making any financial or technological decisions. The fragmented reality of today's blockchains. To appreciate ICP, we first need to understand the current state of blockchain interoperability. Today, the blockchain landscape resembles a collection of isolated islands. Each chain has its own rules, consensus mechanisms, and operational structure. While these chains innovate in their own right, they rarely communicate efficiently with each other. Take Bitcoin, for example. It's extremely secure and trusted as a digital store of value, but it lacks programmability. Smart contracts on Bitcoin are limited, meaning that applications like DeFi, gaming, and NFTs must often exist elsewhere. Ethereum solved programmability with its Turing-complete smart contracts but introduced scalability and cost issues. Solana offers high throughput, but occasional network congestion and centralization concerns limit its broader adoption. Bridges are the most common workaround for cross-chain activity. They allow assets to move between chains, but they come with trade-offs. Most bridges rely on centralized or semi-centralized validators, creating single points of failure. They require users to lock assets in one chain and mint a wrapped version on another. This not only adds complexity, but also introduces risks, including hacks and exploits. According to recent reports, billions of dollars have been lost through bridge failures, highlighting their vulnerability. Even when bridges work, they do not solve the core problem. Smart contracts themselves remain isolated. Developers must rewrite code for multiple chains or rely on external services, which slows innovation and increases cost. The blockchain ecosystem, while rich with innovation, remains fragmented, creating friction for users, developers, and businesses alike. ICP addresses this fragmentation not by patching it, but by redesigning how interoperability works at a fundamental level. ICP's core innovations. ICP is not just another blockchain. It is an ecosystem designed for seamless interoperability. At the center of its approach are canisters, which are advanced smart contracts capable of cross-chain communication. Unlike traditional contracts that operate only within their native chain, canisters can interact directly with other blockchains, executing functions and verifying data without relying on bridges or intermediaries. Chain key cryptography. A key innovation enabling ICP's interoperability is chain key cryptography. This cryptographic system allows ICP to sign transactions, verify external data, and interact with other blockchains securely. Think of it like giving each canister a universal passport that allows it to move and communicate freely across the blockchain world. Unlike bridges that depend on trust in third parties, chain key cryptography ensures every interaction is cryptographically verified. Reverse gas model. Another innovation is the reverse gas model. In most blockchains, users pay gas fees to interact with contracts, a system that can be confusing, costly, and prohibitive for mainstream adoption. ICP flips this model. Developers fund applications with cycles, allowing users to interact seamlessly without managing tokens or worrying about gas. The result is a user experience similar to traditional web apps, dramatically lowering the barrier to entry and simplifying cross-chain operations. Composable architecture ICP also introduces a composable architecture where canisters can call each other, both within ICP and across external chains. This modularity allows developers to build complex, scalable applications that leverage the strengths of multiple networks. Imagine combining the security of Bitcoin, the programmability of Ethereum, and the speed of Solana into a single user experience. ICP makes this possible at the protocol level. Practical cross-chain examples. The true power of ICP becomes clear when we examine real-world use cases. Cross-chain DeFi. Consider a decentralized finance platform built on ICP. Traditional platforms are often limited to a single blockchain. Users must wrap Bitcoin to interact with Ethereum-based DeFi, introducing delays and risk. ICP eliminates this need. A single canister can verify Bitcoin transactions, interact with Ethereum smart contracts, and manage liquidity across multiple networks in real time. This reduces friction, increases security, and enables more sophisticated financial products. Gaming and NFTs. Gaming is an area where ICP shines. Imagine a game where a sword exists on Solana, a shield on Ethereum, and the player's identity is stored on ICP. Traditionally, these assets would be isolated, requiring bridges or duplication to function together. ICP's canisters allow all assets to interact seamlessly, creating persistent cross-chain gaming worlds. NFTs also benefit. Artists can create collections that exist across multiple marketplaces without duplicating tokens. Ownership remains unified, and cross-chain interactions become natural, enabling more flexible and immersive experiences for collectors and developers. Enterprise and Web2 integration. ICP's interoperability isn't limited to DeFi or gaming. Enterprises can leverage ICP to integrate real-world assets across multiple blockchains. Supply chain tracking, digital identity systems, and financial instruments can communicate securely without complex middleware. This capability opens the door for widespread blockchain adoption in sectors where fragmentation has previously been a barrier. Multi-chain wallets. Wallets built on ICP can manage multiple assets natively. Users could hold Bitcoin, Ethereum, ICP, and other assets in one interface. No wrapping, no bridging, no API dependence, just a seamless, secure experience that simplifies asset management. Technical deep dive. ICP's architecture is built for scale, security, and developer freedom. Canisters. Autonomous smart contracts capable of computation, storage, and cross-chain communication. Canisters can call each other and interact with external chains in real time. Reverse gas model. Developers supply cycles to run applications, eliminating user-facing transaction fees and simplifying the experience. Chain key cryptography enables secure communication and verification with external blockchains, eliminating the need for centralized validators. Subnets. ICP scales horizontally via subnets, distributing workload and maintaining performance for complex cross-chain applications. Composable architecture. Canisters can interact modularly, creating scalable applications that operate seamlessly across multiple networks. User-centric benefits. ICP's design has far-reaching implications for users. Seamless experience. Users interact with applications without worrying about which chain powers which function. Reduced friction. No complex token wrapping, chain switching, or gas management. Increased security. Removing bridges reduces attack vectors, and cryptographic verification ensures safe cross-chain operations. Mass adoption. Smooth, web-like experiences make blockchain technology more accessible to mainstream users. Developer advantages. For developers, ICP offers new possibilities. Single codebase for multi-chain applications. Canisters interact across chains, reducing redundant development. Innovation. Without barriers, developers can experiment with cross-chain DeFi, NFTs, gaming, and enterprise solutions without relying on external workarounds. Enhanced user engagement. Applications built on ICP offer smoother experiences, leading to higher retention and user satisfaction. Scalability. The network supports complex logic and high-volume operations across chains, enabling enterprise-grade solutions. Future Speculations ICP has the potential to redefine how we think about digital ecosystems. Internet of blockchains. Users won't know which blockchain powers each application. Assets and data move seamlessly. Cross-chain DeFi. Sophisticated financial strategies could span multiple networks without intermediaries or wrapped tokens. Persistent gaming worlds. Multi-chain assets create global, persistent virtual economies. Enterprise blockchain integration. Businesses could integrate multiple networks for supply chain, finance, identity, and more, achieving operational efficiency at scale. ICP could fundamentally shift how blockchains are used, making interoperability a native, invisible feature rather than an afterthought. Addressing misconceptions. Some questions arise about ICP's approach. ICP uses subnets to scale horizontally, efficiently handling high transaction volumes. Chain key cryptography ensures safe cross-chain communication without centralized points of failure. Complexity for developers. While ICP introduces new concepts, it ultimately simplifies development by removing bridges and redundancy, allowing developers to focus on innovation. Real-world ICP adoption. Even today, ICP is powering innovative projects. Cross-chain DeFi, platforms accessing liquidity from Bitcoin, Ethereum, and other networks seamlessly. NFT platforms, cross-chain minting, and universal ownership verification. Multi-asset wallets, streamlined digital asset management without intermediaries. Enterprise solutions, integrating real-world assets with blockchain infrastructure securely and efficiently. These examples demonstrate that ICP isn't theoretical. Its technology is practical, scalable, and already making an impact in the real world. Long-term vision. ICP's vision extends beyond current applications. The ultimate goal is a world where blockchain interoperability is invisible. Users won't have to think about chains. They will simply use applications, transact, and interact without friction. Liquidity fragmentation will disappear, cross-chain DeFi strategies will become commonplace, and multi-chain gaming experiences will flourish. Enterprises will adopt blockchain solutions with greater ease, creating a more robust, connected ecosystem. ICP's protocol-level interoperability could make the idea of a decentralized Internet of blockchains a reality. The next era of blockchain. We are at a critical juncture in blockchain history. Traditional bridges and siloed networks can no longer support the growing demands of users, developers, and enterprises. ICP offers a fundamentally different approach, one where interoperability is built-in, secure, and seamless. The Internet Computer Protocol is more than just a blockchain. It is a framework for the next generation of decentralized applications, unified, composable, and scalable. For users, ICP means simpler experiences. For developers, it enables new innovation. For enterprises, it creates pathways to practical blockchain adoption. ICP is actively building this connected future today. The applications emerging now are only the beginning. This is not just evolution. It is the next era of blockchain interoperability, and it's happening now. All right, if you learned something new or enjoyed this video, make sure to hit that like button, subscribe to the channel, and turn on the bell icon so you don't miss future updates. Thanks for watching, and I'll see you in the next one.